Okay, 13. So let's look at how we can use simplification to do the exact same thing as we did with the Karnoff map. Okay, so although I've left the Karnoff map on here, please do ignore it. We're just going to focus on simplifying this equation. So how do we do it? First of all, we need to recognize, well, which Boolean algebra rules can I use? Now, in this scenario, if you notice, not D is in both of these things. Okay, so because of that, I can probably pull it out. Okay, so I'm going to start off with not D. And now I'm going to do my kind of reverse distribution, so factoring, I guess, for another word. So how do I do that? Well, notice that I've got my and here, so that's going to go first. Then I'm going to have the leftover, which is not C or or C. Now, if you look at it, okay, if I expand this out again, that would be not D and not C, which would give me this one. And then I'll go not D and not C, which give me this one, and they're all together. So that's correct. So that's the first step I would do. Now I'd notice that here I've got a Boolean identity. Okay, so if something's either true or false, then it's always going to be true, no matter what. So like, go outside if it's raining or not raining. Well, it's going to be one or the other, isn't it? So I'll just go outside anyway. So that will basically become true. So I'll represent that with 1. So that's always going to be true. Now, because one side of my and is true, then it's not going to rely on that at all. Therefore, I can get rid of the and that leaves me with just not D. So very, very easily, I can get the exact same answer I would have got in the Karnoff map, as we saw in the last video, as I would do here. So following those basic Boolean algebra steps will allow you to kind of get the same answer. So in the OCR, you need to be aware of the following ones, which is the laws, so the law of association and commutation. Okay, and long and short of it, these ones are kind of, I mean, they're dead simple. So if I had A and B, you know, it's the same as saying B and A. Yeah, so it doesn't matter the order effectively what it means. If I had A and B and C and D, then I could have D and A and B and C. Okay, as long as the logical operator is the same, the order does not matter. However, if I had A and B or C, then it does matter. Okay, so that's the laws of association and commutation. Okay, then you got the laws of distribution. Okay, and that's kind of like your factoring and then distributing the thing back over it. So that's essentially what I've done here. Okay, then you got De Morgan, and that one is where you've got something like not A and not B is equivalent to not A or B. Okay, so essentially the not gets pulled out and the operator swaps over. Okay, so that's De Morgan, and then we have our Boolean identities. Okay, and there's quite a number of these, and you do need to learn them all. So those are things such as if I have A and 1, it's equivalent to saying A. If I had A or 1, that's equivalent of just saying 1. Okay, if I had A and A or B, that's equivalent of just saying A. I always forget the name of that one, I'll be honest. I think it's got a special name, but that's an important one. And the same if I had A or A and B, that's equivalent to saying A as well. Okay, so in my lessons, I have shown why that's true. You don't actually need to know why, you just need to be able to identify it. So you need to know all your Boolean identifiers. There are others, please do revise over that. So that's how you can tackle the Boolean algebra simplification questions.